Hey guys, welcome to episode 4 of the tutorial series for building the line drawer in Logic World. So today what we're going to do is we're going to grab the counters that we built in the last episode and attach them onto this part of the circuit here. And then we're going to build a dedicated decrementer to do, well, I'll show you, we're going to need a dedicated decrementer to do the cmpt equals itself minus 1. So if we have a dedicated decrementer that saves a lot of time in the loop, then that will be very optimal instead of just using one of these general purpose units. So let's get started by first attaching the counters, and then we'll move on to that. Okay, so here we are in front of the counter that we built in the last episode. We can go ahead and just press Ctrl G on this first panel here, and that will copy it over. And we can actually go ahead and get rid of this completely like that. So now we can just, how I did that was I pressed G and then pressed R. So now we can just press G on that first board, and actually what I'll do is I'll color this first board different, and then this way we know when we pick it up, that's where we can pick it up from. And I'm going to copy and bring it over to where we were working. Now what I'm going to do is I'm going to expand this out a little bit and grab this board again. And, well, before I grab it, I want to show you what we want to do. We want this branch input to come from, well, in this case, it's going to be the Y naught side, and the X naught will be on this side. So, we're basically, the branch inputs are the starting XY locations. We'd like to get this lined up as best we can right here. And we will have to grab this. Oops. We want to grab this here, pull it back. I'll line it up right on that edge. You can use Control for the fine placement. Now what you want to do is Control and drag all the way up like that and select them. And now this is going to be Y naught. It's going to be this first column right here. So I believe that I went from the bottom to the top, but we'll see how wrong I was in a second. Nope, that's what we did. We went from the bottom to the top. Perfect. And now you can see this is Y naught is there. And now we can copy this. Oops, I need to press Control G. There we go. And it doesn't quite fit here, so we will expand this out a little bit. And then we can pull it back in when we don't need it. Control G. Line it up right on the edge there. Now this is our output here, and this is the output for this other counter here. And now we want our X naught position. Beautiful. So now we have set up the program counter so that the branch inputs are the first value, so that when you look at the algorithm here, it says X is equal to X naught and Y is equal to Y naught. The way this notation is written, A is the first point and B is the second point. So because of that, we just need to set the program counters into those on the reset. So the way this is going to work is there's going to be a reset line and a clock line going to this. And when reset line is true, on clock it's going to, set all these initial constants and everything, and set up the for loops with everything at the initial state. So that reset line will control that so that everything is set up properly. And the moment you let go of reset, it starts going through this loop. And that's going to be how this works. So we have very minimal control lines. We just give it the data and hold the reset line true, and then we stop the reset line until the moment it throws the flag saying it's done. And then we stop the clock. So that's how we're going to work this. Hey guys, so what you can see in front of us now is a incrementer here and a decrementer there. And I want to point out what they are, and then we can build them afterwards. So the idea here is, for the incrementer, it's a carry logic where the inputs are inverted, and then the toggle to control whether it counts up or count down is inverted. And then what you can do is, if I turn off all of these inputs so you can see how the default state is, we get zeros out because 1x or 1 is 0. and all of them are obviously filled like that. And what happens is the zeros, all the inputs get passed to the bottom ones alone. So it's just this one to that one to the next one, that one to the next one. So that's really easy. And then it's this one goes to all but itself, this one goes to all but itself, and the one below it, and this one goes to all. So you're always going above but never below with the wires. And so we just will stack them like that. And now you can see if I enter, say, 7, I get 7 out. And then the moment I flip this, I get 8. And you can see it was synchronous. To add 8, I slowed the tick speed down on the server to 5 ticks per second. So you can see that it's synchronous. Now we have the same thing here, but instead of being incrementer, it's a decrementer. So if I turn this off, you can see we're so this should be inverted by default. And you can see right now we're at 0. If I put in an 8, we get an 8 out, and the moment I click this, it goes synchronously to 7. And so we will show you, I will show you how to build this next. Okay, so we want to build a decrementer. We're going to start off by building a little slab like this, pull this up, go up 4. We're going to stick a XOR on it, go like that. We're going to then grab an inverter and put it on the bottom, and we need to hook up the inverter's input to be on the output of that, like that. Perfect. Now we can pull this back one. Now what we got to do is put on our input, which is going to be a buffer like this. Now, hopefully when we stack this, it'll reach enough. So I will pull this with G up to there, press Control G, copy the board, T-E-E, Shift E-E, boom. And grab the second one. For some reason it likes it from there. And we will do this. Now we have 4 plus 1 is 5. 8 plus 1 is 9. And now we have 16 plus 1, which is 17. So now we need to go 17, 16, 15, 14, 13, 12. We want 12 GR. Okay, so now we should have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Now what are we going to do? We are going to connect all the bottom inputs to all the bottom input or outputs here to all the bottom inputs. The XORs like this. Perfect. Now what are we going to do? We're going to take these and connect them up to here. One that each one doesn't get itself or lower. So for instance, this one here will only go to all the ones above it. This one here will only go to all the ones above it. How will you do that? We will select all of them like this and like that. Boom. And you see they all reach. Okay, cool. Now we will grab all but this one and go to the second position there, and so on and so forth until we were done. See it messed up there. Gotta go ahead a bit to go there. Oh, almost messed up again here. I want to go ahead there. Ahead of it to go there. Shoot. Just got that bug. We'll just finish up by hand here. Okay, now hopefully none of these are going to any of their own, except for the bottom ones, of course. Okay, so now what do we need to do? We need a mount. You can slab it there, pull that up a bit, put an inverter on it. We're going to select all of these inputs, and boom. Okay, so now you can see we have zeros on the outputs of our inverters there. Now what happens if we press, say, an 8, we should get an 8 on the output. Boom, we get an 8 on the output. And now if we subtract 1, we get a 7. And it was synchronous. No ripple, no blinking here to 0. It just goes from 8 to 7. Beautiful. So we have our decrementer. Alright guys, so now to finish this thing up, what we need to do is add the clock and input and reset inputs to this user panel right here. So an easy way to do that would just be to, we can, I wish through diodes were a thing, through buffers. Anyway, I think the easiest way to do this is to do it like this. Actually, maybe we can grab that there. Cool. Okay, so I'm going to try to pass these down there. And we can call this one reset. And we can call this one clock. Okay, so now we have reset and clock. And I will just tap them off at several spots along the lines here. Okay, and then to remember what they are down here, reset, clock. Okay, so we have those set up. Now what we can do is go ahead and, well, we can grab our decrementer here and set it up and get ready for this part of the logic here where we say, while compare is greater than or equal to 0, we're going to plot the first pixel, and then we're going to go ahead and start decrementing compare. So go ahead and get rid of this. And if you notice that we always want to be decrementing, we can basically just pull that off like that, and now you can see we're always just decrementing. This is permanently decrementing now. Instead of swapping between decrementing or not decrementing, we just always want it to decrement, so we can just do that. So we can now color the bottom input. I don't know why I didn't color it. There we go. Grab it. Throw it here. Now we're looking for a cmpt. So it looks like cmpt is this guy here. That comes in and gets added with something else as well, so we can pass cmpt off to the side here. We're gonna have to be hopefully, well, let's see if this one reaches. Perfect. Okay, so that's what we'll do. Hold Control to get the fine placement and just get them right in that top corner there. Alright, now select them. And the same thing here. Then we want cmpt. Beautiful. Okay, and now we should just label this cmp, lowercase cmpt. Okay, now let's check the algorithm and see if we understand what's going on here. So something's going on with error plus cmpt, and as you can see, that makes sense. Error is getting inkd plus cmpt, but we also need to get cmpt around to the input so that we can do stuff with it like that. Cool. And we will either get inkd or inks. So do we have inkd? And then what is this here? Is inks over here somewhere? Yes. So then we're gonna have to get inks to pass around here as well. And we can do this. Just label this in the front, cmpt. And we'll label this inkd, I believe that is. No, inks, sorry about that. Okay, and now we can use our through pegs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we can grab inks there by doing this, Control G. And it makes sense, that's still cmpt, so we'll leave that label there. Oops, just missed. Hopefully that works. God damn it, nope. Okay, so we gotta reselect all these. And I don't know how I did that, but okay. So top to bottom. Top to bottom. Boom. Okay, so now we have compare T, cmpt, inks, error here, and inkd. That's the 4 variables we need now to run this loop. You can see inkd, inks, error, Of course, inc y, that's just the increment or decrement flag for the program counters, which we already. Oh, that's what we need to do. Okay, good call. Okay, so here is the inc x flag, and here's the inc y flag. So if this is true, it should be decrementing, right? So our xy increment decrement control is the it's one of these pins here. Let's see if we can find it. It's this guy, right? Yeah, so we could just go right to this. So by default, it's incrementing, and when that's on, it should decrement. Perfect. And now we can do the same thing here. We can grab this and throw it right into there. Beautiful. So there's our decrement flags. Increment, or that's what's telling us inc x or inc y to the program counters. Beautiful. But then we need to then enable the program counters, right? Which one is actually going to increment or decrement? So then these if statements will control enables to the program counter. Anyway, so we'll continue on with this cmpt statement. So basically what we have to do is we have to say cmpt is going to be this thing by default, and then we're going to keep subtracting one from it. So we need a loop, right? So we need a register on this as well. So we'll expand this out a bit. Grab this, and we were looking for cmpt. Stack this upwards, and we want this guy right here. And I will actually pull this over. We can actually do this right here like that, because that can still come up in front of it. So yeah, let's hook up cmpt. Actually, before we do that, we need a register. So we'll do this. Do something like that. Beautiful. And now we can get our data input there like that. Cool. Control G. And the clonk lines that got connected, and we'll just connect our data in. And we can just real quick build this up. Okay, from top to bottom. And we'll grab from top. Oh, we're grabbing the wrong shit. Good thing I double checked. Okay, we'll go from bottom to top now. And we'll go bottom to top. Cool. So now we have data coming in, and now we can just wire these up. There is a shortcut to use the multi-wire placement for this. I still can't get it to work for me, so. And then now we can wire this here to this here. So now, basically what we're, okay, so what we need to do actually is pull this back. Actually, we'll get rid of this. No, we can, okay, that's convenient. We can place in right here some relays. So what do we need these relays for, right? So on the reset, we want this input to come through. And then when we're running the loop, we want it to just use the output of itself. It's decremented by one, not the branch input again, or like not some load input again. We want it to use itself as the next input. So we will hook up these relays, and then now we will hook up all the control to the relay. And now when reset is true, it'll take this path. So we'll put a little pin up here that says reset. Okay. So when reset's true, it'll take this and allow it to go into the data input of here. So when this gets a clock, it'll update. Then what we need to do is take the output of this which is these inverters, and bus it back to the input, which we can probably get to through this side here. If no, maybe we should take it through this side here. So I wonder if we do something like this. Beautiful. Yeah, we can actually do that. So hold control and get pegs set up on the output like this. Then hold control and select down to them. And grab the outputs like that. Now hold control and get a fine select placement on the edge of that board as well. And do the same thing wire them up. Beautiful. Okay. And then what we can do is we want to be able to enable or disable this. And one of the easier ways to do that is if you force ones into the XOR, it'll just it'll have to be 0, right? So we can have basically do something like this. Pull that out a bit. Do this, and we grab every input here, bus it there. It reaches, and we do the same thing here, and we bus it here. And now, hopefully, that's a nice way to force zeros under this thing. Oh, actually, no, we want to do that a different way. Let's get rid of that. And we will actually do that instead by forcing zeros into these inverters here. So let's see if we can actually grab them from that spot over here. Only a few. G. Will this do it? No. Okay, so what we're going to have to do is we're going to have to yeah, we'll do this. Press C to crouch. Alright, this is going to be worth it. This way we don't need extra components in the build. And now I'll select top down. And hopefully, boom, they all reach. Okay, so now we can force zeros on this. So how should I grab it? We'll test it like this. And now all zeros should be forced. Cool. So now, that should be the opposite state of this one here, if that's the reset pin. So we can put a inverter like this, and then tie that to the reset here. Actually, no, that should be a non-inverter, yeah. Okay, so we'll do it like this. Of course, that can't be done. Making that. Making that. There we go. Okay, why did we do it like this? Because right now it's taking this, it'll take this inverted and feed it back into there and not take this one. And then when we power into this, it'll take that. Perfect. So the default state is doing this loop instead. That's awesome. Now we just need to feed these outputs back into the input, which we are setting up currently. And we can do that like this. And we'll modify that one a little bit. Nope, we'll just do that instead. Perfect. And now we'll select these. And bottom to top. and bottom to top. Boom. Okay, so now the output is wrapped back to the input, and on the clock it'll take it. So what else do we need up here? We need a clock input, so we can do this. Grab the clock, up, and boom. Okay. So we have this that we can do this with. So we have clock and reset and clock. Reset clock. Reset clock. Whoops. What? Okay, so clock goes to this right side here, and reset goes to this guy here. Okay. So we have that part of the loop set up. So now, if reset's true, which we should go and enable reset to be true. When reset's true, it should be forcing this data here to be zip. And then this data here is coming from the cmpt line here. Perfect. And that's why you see the cmpt there. And then on clock it would accept that data there. The other thing on reset needs to do is it needs to come over here and tell this to branch. So the reset line is basically like the load the default value line, right? Which would then be enabling this right here. So I don't know if I want to use a diode or not. I think for safety, we will use a diode. And then we also want to then enable this here. So one of the easier ways to do this is just copy this stuff up like this. So the reset is the one that's on right now, so we want reset to come here. Cool. Now we want to grab the clock line as well. And so the clock here, the clock input is this bottom one down here, right? So we want to grab, I will use a buffer for that as well. Grab clock going into there, and that means the one that's not on is the clock. And that means on this side as well, the clock input is the low one there. Which, let's see. Beautifully do that. Grab the clock input like that. And that should go to the one that's on. Cool. So if we hook up a button here and press it, the program counter should get this on the X and that on the Y. But you see, that's what we got on the Y, and on the X, that's what we got on the X. Beautiful. And that's working. And then over here, we should have gotten some values into this register. We should have gotten CMPT, which is exactly what we got. So now this part of the reset circuit's working. And I think we're going to end it here for this part of the tutorial. In the next tutorial, we will add the rest of the loop logic, which you can see is now these if statements, which is actually really easy. It's just a subtractor to check for the comparison here. And then we have to then put some AND gates on the enable of those clocks to the program counter. And then we're done. We hook up the screen and we get the C line. But I think this is enough for today. And I hope you guys have made it this far. Thanks for watching. And I hope to see you guys next time.